Today's lesson is 3-7, Absolute Value Equations and Inequalities. You are going to find this slightly confusing, but you have to memorize the rules. So these are the three objectives for today. And you know that absolute value is the distance of a number from 0 on the number line. So you are aware that if we take the absolute value of +5 or -5, the answer is always going to be 5. So following this process, the absolute value of x, if the absolute value of x is 5, then we can say that x is either -5 or x is +5. So you can get two answers. So let's say we have an equation here, and this says absolute value of x plus 2 equals 9. Just like you isolate an absolute value as a variable, you have to isolate the absolute value. And in this case, this is the absolute value. So we're going to isolate it by doing inverse operations. It turns out that absolute value of x will be 7. And since x can be positive or -7, those are the two answers you're going to write. And then in the final answer, you can put it in a solution set telling me that x has two values, -7 and +7. So let's try another one. Here we have absolute value, which you must isolate, and it is actually already isolated. So that means whatever is inside is equal to either +13 or -13. So you end up with two equations with the word or. This word or is very important. And then you simplify both of these equations. It turns out that x is either equal to -4 or x is equal to +9, and then you put your answer in a solution set. And in order, remember, in the math class we keep things in order. So here's a third one. And here again we want to isolate the absolute value. That means you must now subtract 5 from both sides. When we subtract 5 from both sides, it's telling us that the absolute value of a number is -5. But that is not possible. Therefore, this one has no solution. Now let's try some inequalities. If we have an absolute value inequality with a less than or a less than equal to sign, that is an AND inequality. And you have to memorize the rules. So if x is less than or equal to a number, because it's an AND inequality, it's going to lie between two numbers, just like the line segments you've been used to seeing. And we can say that x lies between the -2 and the +2, which you should be able to graph. And of course, it looks like a line segment. Let's try another one. Here we have 8n is less than or equal to 24. So we can say that 8n lies between -24 and +24. And now you're going to simplify, isolate the n in the middle. Turns out that n lies between -3 and +3, which you should be able to graph. And all of these apply to less than or equal to or just less than. And let's solve some inequalities with a greater than. This is perhaps the most confusing part of the lesson, and greater than inequalities use the word or. So here's a sample. Let's say x is greater than 2. This means that the inside can be more than 2 or it can be less than -2. So more than 2, same thing, you write the same thing, or less than the opposite. Okay, so same on the right and less than the opposite. And then you should be able to graph it. Remember that you're going to get a graph with two arrows going in opposite directions. Let's try another one. Here we have 8n is greater than 24. So 8n is going to be greater than 24 or, use the word or, less than -24. And then you simplify both these inequalities and you graph it. I want you to try 4 questions on your own slowly and carefully, and after you have tried it, see if you get the same answer as I do. You may want to pause the video. And if I have made mistakes, let me know. For this first one over here, please write your answer as a solution set. So you're going to write in a solution set. Oops, the ink is some crazy color. Here we go. It's -9, comma, +9. Here it is no solution. Number 3, try this one, and you should get an inequality. And for this one, you should also get an inequality. These, by the way, are your final answers. It's a little messy, but these are your answers. And I'll see you in class tomorrow. Goodbye.